Live streaming is on.
Cool. Let me check if it works. Yes, seems that we're live. Okay. Put the link in the chat for the live stream. Cool. So I guess I think we mostly know each other from other calls, but is anyone new here? Hasn't been here for either the 0th one or the first one?
I think I'm new. I don't know if anyone else is.
Cool. I guess we can do like a short round of introductions then. Then can you start, ballestar?
Yeah. So I'm a software engineer at Nameless. I'm focused on like infrastructure work for a company as well as smart contracts. And I'm starting to get into ZK. And so I'm hoping to learn more through stuff like this.
Cool. Okay, so I'll introduce myself. I'm dcbuilder. I work as a research engineer for WorldCoin, a privacy-preserving proof of personhood protocol. And yeah, I'm very excited about ZKML. I started working with Jason on his project, that is creating zero knowledge proofs or circuits for machine learning algorithms. And yeah, I created the ZKML community and trying to get like a community of people interested in like discussing different topics that they're working on, and like news and different papers and whatnot. Cool. I guess somebody else can go.
Okay, I'll go. Hi, my name is Dor. I'm a postdoc at UC Berkeley. I'm working with Shafi Goldwasser, and we're developing ZKP systems for legal use cases. And I'm interested to see what people are doing over here with zero knowledge machine learning. I'd love to learn about some works that people do here. Nice to see you.
Hey, I'm Jason. I'm working on this ezkl project to put models into snarks with dcbuilder and some others. Just excited to go to space and figure out both what the best techniques to do things are and the most interesting applications.
Hi, I'm Jonatan. I'm VC at Inflection, and yeah, hobby researcher, I'd say, in this space. Yeah, I would love. Is there any resource to find out more what you're building, Jason, and dcbuilder?
Yep. Let me share the repo.
Cool.
I posted it in the chat. Also, I created this bit of aggregator of different ZKML resources. I posted that as well.
Can also, I guess, follow up. Also, investing in research at Inflection. Super curious and interested in the overlap of verifiable compute and machine learning. Mostly just exploring use cases, seeing how the space evolves.
Alrighty, hello everyone. I'm Ryan. I'm the CTO at Modulus Labs. Just graduated Stanford last year with my degree in AI or whatever. And yeah, we're working to basically push modern ZKP systems kind of to their limits and figure out how fast and how large models they can prove.
Yeah, hi everyone, I'm Lakshman. I graduated this year. I work at a crypto VC called Tioga, also on the investments and research side, and yeah, interested in this space.
Cool. I guess that's everyone from the people who want to speak. I guess we can start like discussing whatever things. Like if you want to discuss everything, anything, just like bring it up. Either like raise your hand if somebody else is speaking, or just start speaking. I guess like that's the simplest way to do it. Cool. I don't know. Does anybody want to start talking about anything?
Maybe I could ask a question, which is there anything that this imagine this technology was farther along? Is there anything we could have done to, prevent some of the stuff that's happened in the last few weeks?
By that you mean like the whole FTX thing?
Yeah, I mean, so one application obviously is if we had some more fraud checks or ZK, KYC, those are possible things that might slow things down. But I don't know, just sort of open. Yeah, I mean, obviously it's a centralized situation, and there's not much that you can do against that kind of just blatant fraud. But yeah, it's just worth thinking about. As we go, that's what questions a lot of people are asking in terms of how we can build space more responsibly and stuff.
Yeah. I don't know specifically about ZKML, but Vitalik has this blog post about using ZK snarks in general to do like proof of funds, but like actual proof of funds on chain, not just the proof of reserves that you do using a sum check of the Merkle tree to check balances. But like this one would be like more robust, because they would prove like different addresses, like the existence of those funds in different addresses, and various other things. It's a really nice blog post. I put it in the chat for everybody that's interested.
Yeah, thanks for sharing that. I think that's where I was kind of curious if beyond just proof of reserves, if there's a way to natively combine proof of reserves with some sort of on-chain or trustless chainalysis. It would be particularly interesting.
Yeah, there's a bunch of things you can do. I haven't fully read the blog post yet, but there's some ZK snark techniques where you can make attestations to the funds actually being there without revealing like private information about like the actual addresses in cold storage.
Does it drill down to the level of individual accounts?
I think so. Yeah, I think the current Merkle root or Merkle tree approach is that you as a person can input your address, and you can verify that you're indeed like fully backed by this in this snapshot, like your funds are fully retrievable. But like it's still a ways off from like the guarantees that a decentralized exchange can provide. So like there's like the spectrum that Vitalik outlined. There's like on the left side you have don't be evil, on the right side you have can be evil, and it's like a spectrum of different ways a centralized exchange would work. So you have on the leftmost side, you have the fully centralized exchange with no controls. Then you have an external human that controls the exchange with using auditors and like having different like audit companies giving you sort of trust into the exchange. Then there's proof of solvency. That's what we talked about this week in CT in general. Just like where people were like, okay, all these exchanges like Binance, Coinbase, they need to provide not only audits but actually proof of reserves, like cryptographic proofs of Merkle tree that they actually hold all their funds or all the funds that they're stating they own. Then there is a non-custodial centralized exchange, right? So you have all the centralized all the funds on essentially their smart contract wallets that are like maybe like multisigs, and users can like easily withdraw certain amounts. But the centralized exchange can still cheat through like front running and some other attacks, but they cannot steal the funds. right? So like even if they wanted to, they would have to do like an on-chain proposal to like move the funds from some cold storage wallet or some cold storage like Gnosis safe multisig. And the most can't be evil solution is just like a fully decentralized exchange, i.e. Uniswap, SushiSwap, any of the other major ones like Curve or whatnot.
So I might throw out again more of a question than sharing information, but has anyone seen any good resources or documentation around potential applications and I don't know, any comparison of performance for verifiable models and how that kind of like weighs against potential value that's either been perceived or measured of running models in this way? I know it's very hard to quantify the usefulness, but
yeah. So for use cases themselves, I have a running list on the awesome ZKML GitHub. If you want to like if anybody like thinks of any use cases, feel free to submit a PR. I just like listed the ones that I've noticed, whether it's from Modulus Labs, we partner with different protocols to build different solutions using ZKML, or from us at WorldCoin, where we're doing like an identity layer or to create an anonymous proof of personhood protocol. And from different like projects in the space, whether it's like people that are looking to build custom hardware and other things. In terms of like benchmarking performance of different like proving systems and like how does that apply to ZKML, I think it's like too early to have any like robust benchmarks. Many people are trying different things. There's people from the Starknet ecosystem that are building on top of Cairo. Cairo is this like domain-specific language, DSL, to write on top of the Starknet L2 or layer 2. So it's essentially this language that's able that you can create Starks, or like it's like saying scalable, transparent arguments of knowledge for, right? So you can create Starks of any computation, and if you represent that computation using Cairo, let's say a machine learning model using Cairo, then you can create a zero knowledge proof out of. So that's one way that people are doing it. Then there's people that are using just like the bare bones proving system and trying to create circuits using their APIs. There's some minor work that's been done using Circom. Circom is another DSL that is like tailored for the Groth 16 proving system, but that's very slow, and people like have not been able to create like very big models. If not any model, it's mostly just like parts of the model, like different layers. I've seen people, for example, me and Jason, or Jason started this project along with some other people, and I joined recently. He's using Halo 2, which is the proving system used by or developed by the Zcash team or the Zcash Foundation. And there's some experiments that we created at WorldCoin where we're trying to like use Plonky 2, the proving system created by the Polygon Zero team, which uses essentially this construct of a Stark that is recursively proofed instead of a Snark. So you can create essentially a zero knowledge proof out of a zero knowledge proof, and thus compressing it a couple times. And you have like a smaller proof that's also quite fast. We haven't really done a lot with Plonky 2. And right now, in terms of like viability, I guess like the most, like the best positioned project that's doing like ZKML and like I think like is the most promising is probably ezkl. That's why I started like contributing to it, or just looking into contributing right now. Some other stuff. So there's been a few papers. There's this paper. Let me find it real quick. By Daniel Kang. Yeah, Ryan, feel free to speak.
Yeah, actually, I was going to mention basically the Daniel Kang paper. They have some comparisons in there, and they actually snarked a efficient network, so MobileNet, Basically, the idea there was, I guess, like traditional convnets are humongous, and they're like, okay, well, we want these things to run on mobile phones. And so this group of researchers out of Google basically came up with a bunch of optimizations like depth-wise separable convolutions and things like that to basically get the architecture small enough to, I think something like 3.4 million parameters for MobileNet v2, if I remember correctly. It might be a little more than that, but yeah, the point is they were actually able to put it through Halo 2, which is pretty awesome. I don't know if there's source code available for that yet. The other thing I was going to say is that, yeah, in terms of performance comparisons, actually, we've been working specifically on this. So we recently gave, I guess, a talk at ZeroX Park, a very short lightning talk, basically comparing Halo 2 and Plunky 2's performances, especially. We're also trying out some other prover systems, but we don't quite have, I guess, these results yet. Yeah, so we'll be publishing these as soon as we get them.
I just wanted to mention, so I was looking through the CarML weekend Notion page from ZeroX Park. That was a great resource, by the way. There are two benchmarking slides in there in one of the talks, I think. So one is, I just posted it in the chat, one is for CK systems, and one is for ML specific. So I guess a combination of these would be something you would have to go for. And maybe this is not ML specific, but just a kind of checking my own knowledge here. But is there any practical difference between working with a Stark versus a Fry snark using Plunky 2 or something?
Yeah, there's a pretty big difference. So I think maybe to be a little more precise about Starks, I think Starks are the combination of kind of two main techniques. So on the front end, you have basically error arithmetization, in which you effectively have this giant compute table. And actually, this is kind of why I think LE invented basically error. In that within error, you can almost think of it as basically a computation trace table, the same way that basically Cook-Levin does it in like the classic like kind of three sat reduction from MP, right? So the idea there is that basically you have a bunch of registers. So you can imagine like the rows across the table, your register state, and then the columns are going to be like your time dimension. And you can basically apply local constraints. So you say like, yes, in each computational step, my register state is allowed to evolve this way. And that is how I am simulating computation. So you can imagine that this is really good for basically like a VM, because a VM proceeds kind of in steps with the registers being updated. So that's kind of like the front end for Starks. For Plunky 2, the front end is basically a Plonk-ish front end. So you have like Plonk constraints, you have your Plonk table, and the only, I guess, like main similarity between the two is that they use Fry as like the low degree testing part for the actual poly commit. So in both schemes, you need to do poly commits, and it just so happens that I think Plunky 2 kind of like ripped the Fry plus like Merkle tree poly commit from Starks. Yeah, so I hope that's clear.
Right. Yeah. So technically, I knew there was a difference, right, in the arithmetization, but I thought more like practically in terms of what the proofs look like, what the process looks like. So the trusted setup is done away with in both cases, right? Yeah. Is there one that that you'd say is better suited for VMs? Yeah, that makes sense. But for any ML specific operations, or I guess for anything generalized compute, you'd still need that structure wouldn't really affect how well or poorly you can perform, say, a large multiplication or something.
Yeah, so I would say that for ML specifically, error representation does make it a little difficult to encode certain types of neural nets. So for example, neural nets with basically like residual connections or skip connections are a little tough in error because, or at least if you, I guess, like represent it naively in some sense, because your constraints within error can't actually refer to rows above the row, like above yours, like directly adjacent to yourself. So in that sense, If you wanted to do like RNN, LSTM, any sort of like sequential application, even like a feed-forward neural net, AIR is probably pretty good for. But again, when it comes to just like more convoluted architectures and things like that, you probably want to stick with Plonkish arithmetization. The flexibility is just basically much better for that kind of thing. Yeah. And then, yeah, when it comes to like, I guess, VM stuff, probably AIR is going to be slightly better just because it's like structured for that. Although I guess if you want to talk about building like RAM into your circuit or other things like that, I guess I'm not really a ZKVM expert, but I'd imagine that you'd need basically other arguments alongside like the usual kind of AIR arguments. Yeah.
I would like to ask a question. Maybe it's a bit basic, but I'd love to hear about your opinions. When I implement a machine learning model in zero knowledge, one prominent problem is that usually in ML models should work with floats, like with floating number arithmetics. And in most zero knowledge applications and systems that we have, we're using like a finite filter, something like that. So you should come up with some way to overcome this thing of floating arithmetic and finite filter arithmetic. So I'd love to hear about different ways to cope with this problem that you're aware of.
Yeah, for the most part, people are doing what you'd expect, which is a fixed point arithmetic, with some kind of fixed or variable denominator, and just using the field to represent that. Although there's other possibilities, right? I mean, so the very extreme possibility is Risc Zero gets really fast, and we run PyTorch on Ubuntu on Risc Zero, and we're done, right? Or more practically, maybe someone comes up with a good floating point arithmetic scheme. But for now, it's mostly fixed point. You can also do stuff like clever embeddings where you pack multiple multiple floating point numbers, multiple integers into a single field element, stuff like that. Yeah, I'd say that there's a lot of quantization that happens on the ML side, although the goals of that quantization are different because they're more about hardware speed and inference speed, and they're not sort of obligate quantization. So typically in those models, they'll have quantization and dequantization steps, and they'll keep the floating point numbers around. And we don't have that luxury, at least not until we have sort of a floating point implementation, or if you do a bit, you can do a bit decomposition and do it the long way. But as far as I know, nobody's achieved that yet.
Okay, I guess I can talk about two things that are slightly ZKML related, but not quite. They're more like educational slash more like educational resources that I wanted to mention that are like pretty current at the moment. There's this course run by Tor from previously from the Entropy XYZ team, and essentially just like a Rust and cryptography course that's like 4 months long. I want to share it here so that you guys, if anybody's interested in like learning how to implement different cryptography primitives and learn the basic mathematics for a cryptography and implementing those primitives using Rust, I'll leave the course here. And also that the ZK hack 3 competition is kickstarted or was kickstarted like 2 days ago. So if anybody wants to like participate in a ZK competition, then join the ZK hack Discord and you can take a look at the prompts. share the links here quickly.
Yeah, I can highly recommend joining just the Discord also for really good learning resources in terms of Rust, but also basic crypto stuff. Here's a link to the book, by the way, that they're following in the group. Exactly, it's really nice. It's like, I guess, like 12 years old now, but it's still pretty unchanged in terms of the fundamentals. I don't know, are you guys part of any study groups? Are you doing the homework?
Yes, I'm participating in the Uncloak Crypto course. Just today and tomorrow, I'm going to be doing the first week's assignments.
Cool. Yeah, I'm doing the reading, and maybe the assignments, but not committing to any study groups.
Is it self-paced, or do you have like cohorts for it?
They're recording everything, so I guess you could follow along asynchronously if you want to.
Yeah, you can do that, but they also want to like have this like they like created this like matching day or 2 days where you could like join different groups, like with up to 5 people, and just like if you want to go along the same material with someone, then you can. That's like the synchronous 4-month thing, but like the coursework and like all the assignments and the lectures are all recorded and uploaded. The first week lesson, or like the intro to the course, just happened, where you had like 2 chapters to read from the book that Jonatan mentioned, and you have like 1 programming assignment, and the rest are questions from the book.
Cool. Is it? I assume it's too late to join a group.
Oh, it's not. It's not. Definitely not.
Okay.
It literally started like 3 days ago, 4 days ago. Like the first week doesn't even ended yet. It ends this Friday. This Friday that you have like another lesson, another like whatever.
Okay.
But you can submit the good thing about doing it synchronously is that you can submit your solutions through GitHub, and like people will probably take a look at it, as long as it's like not something too complex. So like Tor and like the other people that are helping running the course will like help you with implementation. Like if you have questions, like they will review it and everything. It's pretty cool.
Cool. And how do I join?
So join the Uncloak the Discord. Let me send the link real quick. And there you have different channels where you have like you can like talk to different people. You can maybe join like a study group. You can submit your work. You can see the assignments. You can see the Google Calendar for the sessions, right? So you can like join different ones. You can see the schedule, all that, like all the details. I just sent it in the chat.
Sweet. Thank you.
You're welcome.
Hey guys, just wanted to recommend a book that is also cryptography in Rust. It's being developed right now by a team that works in Zero Knowledge. It has good resources, and well, it still needs some improvement, but I will try to reach to one of the authors to come in one of these community calls. I think they know a lot, and maybe it can help with some of the educational stuff.
Cool. Thanks for sharing. I'll share with Tor from Uncloak as well. Maybe it's interesting to contribute to. do we want to talk about anything else? Like, if not, we can maybe like, if you guys have like other things to do, we can probably end it here. We don't need to go the full time that we have scheduled.
I want to say that it's very nice having this talk and listening to what people are doing. I think that I'd also be happy to have maybe longer and perhaps in smaller groups discussions about specific things. So I don't know, I can tell you what I'm interested in, and if someone is interested in kind of the same things, then I'd love to make a maybe one-on-one or like a small group meeting and further discuss maybe more concrete ideas and projects that I'm working on, if someone is into it.
Yeah, for sure. I guess you can message the ZKML chat, the community on Telegram. You can like talk to different people, and like maybe if you want to like have some like more focused, like feel free. Like we're just trying to like run this so that we like people know what's happening. If there's anything new, like people can discuss it or just like update on state of the art, new things that happened. I guess that like things that we mentioned before in previous calls were that bi-weekly might be too frequent of a time. Maybe like monthly is better. I guess that's a good thing that we could do moving forward is maybe like have like a running agenda. So the way that, for example, Ethereum does it for meetings, or like the Ethereum Foundation and like different organizations, is that they keep a sort of issues board where on github.com you create on specific repo like an issue with an agenda for a different like for a specific talk or like for a specific meeting. So we have like things to talk about and there's no like this silence. So like I guess I can do that moving forward. Like I can just create this repo. Well, actually Emiliano Bonassi also already created a repo for the community call, so I guess we can just do it there. Yeah, people can like create issues there and like submit topics to talk about so that we can have like an agenda of things to go over and like discuss.
Yeah, that sounds great. Another suggestion that I'm not sure how to do it, but I think it would be great if we'd have. It's like on the Telegram chat, everyone like once in a while they post things, but I think it would be cool if we had somewhere on the web like 3 kind of folders or something with one like academic papers published or on archive over these issues, and another thing is links to GitHub repos with things that people have done, and the third folder with kind of use cases or something like that. And when someone posts something on the Telegram chat, then if I miss it because there's lots of messages and I don't always get everything, we can have like this, I don't know, folders that are accessible to anyone, and anyone can upload resources over there, and anyone can just read from it and see what people are working on. I don't know what's the best solution to actually do this kind of thing, but I think it would be cool.
So like an aggregator of resources that to see what people are working on, or
yeah, like some, I don't know, I'm not sure what's the best solution to do it, but some website where whenever any one of us in the community has a new paper or wants to share some GitHub repo or came up with a new use case, then there would be this website where you can just post it, and when people want to look it up, they'll like have it organized. Here are academic papers, and here is GitHub links that work on that. But I'm not sure what's the best way to do it. I don't know if we should make a website or maybe a joint Dropbox account that everyone has access to, or I'm not sure what's the best way to do it.
Yeah, so for that reason, I created the awesome ZKML GitHub where I'm listing like all of the resources I find. It's an open public GitHub. If it becomes like like I have it on the WorldCoin organization, but I'm like happy to move it anywhere else. Like if we create like a ZKML, like a joint initiative, GitHub or whatever. But like this one, if anybody wants to contribute, feel free to submit a PR with like a new paper, new resources, or anything that you come across that's like ZKML related, or even like tangentially ZKML related. Like there's people that, for example, created like this AI algorithm that's able to do some like matrix multiplication more efficiently. That's completely related, so you can list that or whatever. It's just better because you have like version control and things. Other than that, we can also create like a website, just like a landing page for like to share with people that are maybe like less technical and like want to be or like want to just learn the basics. Things like an FAQ about ZKML. That's just like a static website hosted somewhere, or like a ZKML community website or whatever. We can have like different things there.
Yeah, that sounds great.
Okay, so I guess I could put that on my task list to just like create like a simple website where people can easily like post different resources. Like landing page for different teams like that are working on ZKML that are interested in, so that people can have like awareness about people working in the industry, linking to the GitHub where we have like things, linking to the talks, seeing like a schedule, things like that. What repo would be the issues board? So Emiliano has this repo for the recordings and like the notes. Let me find it. ZKML community calls. It's this one, I believe. So I guess we can use this one for the issues board, right? So you have like, if you go like on the top left, you have a sort of like a navigation bar. We have like code, issues, pull requests, whatever. So you can click on the issues, like you can create new issue. Community call 1 happened on the 7th. So now we had, today is the 23rd. So then in 2 weeks, like we can create like another issue, right, with all the information. We can create an issue for this week and then for next week, right? And we can have like an agenda, things that we want to talk about. We can like add it there. So that like when I create, for example, like this notes that I'm creating, the notes are on the very top of the chat if you want to see them, the hackmd file, right? So like when we have the hackmd file to begin with, like everybody can see what we're going to talk about or things we can talk about during the call. Yeah, 100%. Maybe 3 around sharing learnings, conclusions from discussions, if there are any. Yeah, 100%. Okay, are there any other things that anybody has on their mind, whatever it may be? Okay, I guess not. So I guess me and Emiliano will create the issue for this week and for the next week, so we can have an agenda, and I'll share it in the ZKML community chat so people can start adding things. And I'll upload the notes. I'll just finish up some notes that I have from my memory, and I'll rewatch the video and just like put the like summarize the video like with things that we discussed. I guess, I mean, I don't know if like after the live streaming ends, if the recording will be available on YouTube by default. Is that how it works? I presume so.
Yeah.
Okay. So I'll like put the video link in the community calls repo as well. Cool. I guess we can wrap it up if anybody doesn't want to talk about anything else.
Thanks, guys. Bye.
Cool. Have a good one, guys. See ya in 2 weeks.
Yeah, bye-bye.
Bye.